So this is Integrated 3, Chapter 3, D-Day number 1. And these first two problems are systems of equations. For the first one, what I am going to do is I notice that the 2, the 4, the 16 are all divisible by 2. So I'm going to divide them all by 2. And I'm going to get a x minus 2y is equal to 8. Now what I want to do is I want to end up with the same number but different signs in front of my x's or my y's. I'm going to use elimination. So I am going to try to get the x's to be the same but different signs. So I am going to multiply the top equation by a -5. Everything in the top equation by a -5. So I'm going to get a -5x, a positive 10y, a -40. The second equation is 5x plus 7y is equal to 6. I'm going to add them. I get a 17y is equal to a -34. I divide by 17 and I get a -2. That is the y coordinate. I need to find the x coordinate. I'm actually going to put it into the one that I divided by 2. The x minus 2y equal 8. It doesn't matter which of the equations. They all will give us the same answer. So I'm going to have x minus 2 times -2 is equal to 8. So x plus 4 is equal to 8. So I'm going to get x is equal to 4. And then my point, you have to write it as a point. Okay, we're trying to find the point of intersection, 4, -2. That is our answer. Now, I used elimination on this one. On B, I'm going to use equal values. Okay, so on B, I have a square root and a linear graph. So I am going to take the square root of 6 minus 9x and set it equal to 3x minus 8. Now, when we have a square root, we are looking for the principal root. So we do not want negative here. Okay, we don't want a negative. So at the end, I'm going to have to check my answer. I also don't want a negative underneath my square root. So I'm also going to check that. So let me just rewrite this problem. So I'm going to have the square root of 6 minus 9x is equal to 3x minus 2. I am going to square both sides. Now, when I square the square root, I get a 6 minus 9x. When I square a 3x minus 2, remember, is a perfect square trinomial. So either take 3x minus 2 times 3x minus 2 and either FOIL or do the box method, or remember that if I have an a minus b squared, the formula is square the first one, a squared, multiply these together and double it, so -2ab, and then square the last term, which is going to be a b squared. So I'm going to square the 3x, which is a 9x squared. I'm going to multiply these together, which is a -6x. I double it. It's a -12x. I square -2 and I get a 4. So now I want everything on one side, 0 on the other to solve this quadratic. So this is going to be 9x squared. I'm going to add 9x. So it's going to be a -3x. I'm going to minus 6. So that's going to be a -2. Now I'm going to do factoring. So I'm going to do a box to diamond. I have a 9x squared, a -2, which is a -18x squared. That needs to add to a -3x. So that's going to be a -6x and a positive 3x. And then to figure out what multiplies to this 9x squared, it's a 9 and a 1 or a 3 and a 3. 9 and 1 will not work because of the 6 and the 3 that are there. So I am going to have a 3x. Let me rewrite that. A 3x and a 3x. This is going to be a -2 here. This is going to be a +1. So I'm going to get 0 is equal to 3x minus 2 times 3x plus 1. And so that's going to give me a 2/3 for one answer and a -1/3 for the other answer. And I am going to have to take these and put them both into this 3x minus 2 to make sure that I do not get a negative. So when I take 3 times 2/3 minus 2, and I do that math, I am going to get 2 minus 2, which is 0. So that's okay. So that means that this one is going to be one of my answers. When I put the other one in and I go 3 times a negative 1/3 minus 2, that's going to give me a negative 1 minus 2, which is a negative 3. So that one is not going to be an answer. So 2/3 is the only answer. The other answer we call an extraneous solution. Okay, on number 2, we have a system of equations again, but this time we're going to do it by graphing. So I am going to plot this one, let's say in purple. So when I'm doing that, I'm going to start with the y-intercept, which is 2. I am going to go up 1 over 1, 2, 3, 4. Down 1 over 1, 2, 3, 4. And then I'm going to draw my line. And that's my first equation. Now for my second one, what I'm going to do, let's just put arrows on these. I'm going to graph that one, and let's say I graph that one in red. So this one, you can either get in Y form, okay, or another way is to find the X and Y intercepts and plot those. That's how I usually do it, especially if the 3 and the negative 2 both divide into the 6. So when we're doing this, what I'm going to do is I'm going to put 0 in for my X. And when I do that, you'll notice that this term here is going to become a 0. And I am going to be left with negative 2y is equal to 6. And so when I solve that, I'm going to get y is equal to negative 3. So I'm going to have a point at negative 3. That is my y-intercept. And then I'm going to do the same thing, but this time put the 0 in for my y and see what I get. And again, when I do that, this term right here is going to go to 0. And I'm going to be left with 3x is equal to 6, or x is equal to 2. And so let me put my x-intercept here. So I'm finding my x and y-intercept. Now, if I want to be accurate with my slope, I'm going up 1, 2, 3 over 2, 1, 2, 3 over 2. You see they both are going to intersect right there, right here. Let me just draw my line. I'm going to extend it here also. That's not the point. Okay. And again, our whole point of doing this is to find the point of intersection. And so the point of intersection is going to be this point right here. That's where they intersect, and write it as a point 4, 3. And that is our solution. On the next one, it's a system of inequalities. You have to shade when we're doing inequalities. So for this one, the first graph that I have, I'm going to do this in blue. So for this one, this is an absolute value graph. I have 2, 3. This is saying that this is going to be a solid graph, solid curve, or in this case, line. And I'm going to shade because it's less than or equal to below. Okay, that's what that's going to tell me. So when I'm plotting this, I am going to go to 2, 3. And then this -3 is my stretch, but since this is a absolute value, which is linear in nature, I can think of it as a slope. Only for absolute values am I going to do this. I'm going to go down 1, 2, 3 over 1 in both directions. So I'm going down 3, out 1, down 3, out 1. Okay. From here, down 1, 2, 3, out 1. Over here, down 1, 2, 3, out 1. And so forth. And this is going to be a solid line. So let me get my line. And I am going to draw this. And for this, again, it is solid because of the equal. And it is also, I have to shade. So for this, we want to shade below. So I'm going to take my blue and I'm going to shade below. And if you're trying to figure out where is above or below, if you go to your vertex, let me just color this in. If you go to your vertex and you go up, that's above. Okay, that would be everything on the outside of this absolute value. If I go down, you see I'm below. That ends up being everything inside of this absolute value. Okay, the next one I'm going to be shading in yellow. And I'm trying to see where I basically get green. Okay, but I'm going to be graphing this. I'm going to be graphing this in black because it's going to be hard to see the yellow. Okay, now this one is going to be a parabola, and my vertex is at 1, -4. This is going to be dashed, and it's greater than, so I'm going to shade above. Okay. So I am going to go to 1, -4, which is right here. Now, this too is a stretch, but I don't do it like an absolute value. I don't go up 2, out 1, up 2, out 1, or else I will get a V. This is not linear. This is a quadratic. It is a parabola. I am squaring. So I'm going to go out 1. 1 squared is 1, double it, 2. Okay, in both directions. I'm going to go out 2, 1, 2. 2 squared is 4, double that, 8. So that's 4, 5, 6, 7, 8. Now this is going to be dash. So I'm going to come here and get a dash stroke. And I am going to draw it. And again, this one I want to shade above because it's greater. So let me come and get my yellow. Okay. So if I go to my vertex and I go up, I'm above. Above in this case means it's going to be in between, inside of it. If I was going less than, that would be below. That means I would have gone everywhere outside. Okay. So again, I want greater. So I'm going to go above. It's everything inside. So let me shade everything inside. And wherever I have both colors, that is going to be my solution. So the place that I had both colors, let me just kind of re-emphasize, that was my blue. This is my yellow. So really blue and yellow make green. So I'm really looking in this region right here. Okay, that region is really where my solution is. And you can just write, or I should say shade, just that region if you understand that's where it's going to be. Okay. But sometimes it's helpful to shade one in one color, one in another color, and see where they have the same color. So any point in this region is my solution. Any point on the dash is not, because that's not included. Any part on this solid part that's inside the shading, bounding that shading is. Okay. On number 3, this section is solving. So first thing I'm going to do when it is an absolute value, I need to get my absolute value by itself. So I need to get that absolute value by itself first. So I am going to have 5 times the absolute value of x minus 2. I'm going to minus 3 from both sides and get a 15x plus 40. Now I'm going to divide by 5, divide by 5, divide by 5. And when I do, I'm going to get the absolute value of x minus 2 is equal to 3x plus 8. At this point, I would look to where my absolute value is isolated. This cannot be negative because when you take the absolute value of something, you always get either 0 or a positive. So at the end, when I get my answers, I'm going to need to check them here. So I'm going to write my 2 equations, okay? One equation is going to be x minus 2 equals 3x plus 8. The other equation is going to be x minus 2 equals the opposite, which is a negative 3x minus 8. You make everything that in that circle opposite. I'm going to solve. I'm going to minus x from both sides. And I get negative 2 plus 2x plus 8. I'm going to minus 8 from both sides. So I get a negative 10 is equal to 2x. And I get negative 5 is equal to x. My other answer, I'm going to add 3x to both sides. I get 4x. I'm going to add 2 to both sides. And when I add 2, I get a negative 6. I'm going to divide and I get a negative 6 over 4 or a negative 3 halves or 1.5. Now remember, I need to check these. I need to make sure that these do not make that 3x plus 8 into a negative. So when I put in 3 times negative 5 plus 8, that's going to be a negative 15 plus 8, which is a negative 7. So this one here, not going to be an answer. Extraneous solution. For the other one, I'm going to have 3 times, let's say, a negative 3 halves plus 8. And when I put that into my calculator, I end up getting a 3.5, which is positive. So that means this one will be a solution. Okay, so the next one is an exponential equation. And so for the exponential, what you want to do is get both sides to have the same base. So I want a 2 and a 128 to be the same. I cannot make the 2 bigger because if I make the 2 bigger, that means I'm going to end up also making the 128 bigger. So can I rewrite 128 as 2 to a power? And it's actually going to be 2 to the 7th is equal to 128. So I am going to rewrite this as 2 to the x plus 2 equals 2 to the 7th. And when I do that, once I get my my base is the same, okay, that means that that x plus 2 has to be the same as a 7. So I'm really going to be working out x plus 2 equals 7, which tells me x is 5. And that's your answer. C is a square root. So again, when you have a square root, this has to not be negative. Cannot be negative because this is what we call a principal root. It needs to be positive or it could be 0. And again, underneath the square root, we also don't want to have a negative. Okay, so let me just rewrite this problem. So I have the square root of 5 minus x is equal to 2x. I am going to square this side and square this side. When I do that, this is going to be a 5 minus x, and this one, when I square 2x, is a 4x squared. Get 0 on one side, everything else on the other side. So this is going to be a 4x squared. I'm going to add the x. I'm going to minus the 5. And now I am going to do a box to diamond to factor. So I have a 4x squared. I have a negative 5, which is a negative 20x squared. And then I'm trying to get that middle term x. And that's going to be a 5x and a negative 4x. A 5x and a negative 4x. So when I'm working this out, a lot of times you think of 4 as 2 and 2, but because of this 5, I cannot do that. Okay. So I'm going to have a 4x and an x instead. 4x times a negative 1, x times a 5. So I'm going to get 4x plus 5, x minus 1, x is equal to a negative 5/4, x is equal to 1. Now, again, remember, we need to check our answers because we cannot have that be negative. So when I do that and I go 2 times a negative 5/4, that's going to be a negative 10/4. So that means this one here, not an answer. That's an extraneous solution. When I do this one and I go 2 times 1, obviously that's going to be a positive. So this is going to be my answer. On D, this is an inequality. Okay, so this is when I have to get on a number line and give an inequality answer. So what I'm going to do is I'm going to get 0 on the other side. So I am going to be minusing 12. So I get a negative 15. I am going to factor this to get my boundary points. So that's going to be an x plus 5 and an x minus 3. That multiplies to negative 15 and adds to 2. Okay, really, I'm doing this. What multiplies to negative 15 adds to 2, 5 and negative 3. So one boundary point is going to be negative 5. The other boundary point is going to be 3. So on my number line, I am going to have a negative 5 and a 3. And I'm going to be looking here at this where I have it greater than or equal to 0. The greater than or equal to part of this is going to tell me that I want this to be solid here and solid here. That's where it equals 0. Okay, that's where it equals 0. Now, you can test a value here, here, and here into the inequality and see where it makes it true. The way I like to think about this is a parabola here, okay? And if this is my y here, okay, I want y's that are bigger than 0. I basically want, where's my parabola? Above the x-axis. So if I think of this as my x-axis, because this is where my x-intercepts would be at negative 5 and at 3, I am going to draw a positive parabola. So I'm going to be starting above. And as I'm drawing this from above, you'll notice that I am above this, greater than this line. Here, I'm at this line. As I continue in between negative 5 and 3, I'm going to be below. Okay, I'm below the line. Okay, so this is less than or equal to. And then as I go up, this is above this line. That's going to be greater than or equal to. So this part here is greater. Let me write this smaller. Right here, this is greater because I'm above. This is, whoops, less than because I am below the line. And here I am above, so that's greater. And so where do I shade? Well, I want it to be greater than or equal to 0. So I am going to be shading, number 1, that's going to be closed dots. Okay, and then I'm going to be shading where it's greater. So I'm going to be shading out. Okay, let me just draw my cleaned up answer. Okay, so I use that parabola just to kind of help myself figure out where to shade without having to plug in values. So again, this is where it is 0 at those 2 points. This is where it's greater than 0. And then my answer is an inequality. I'm going to have 2 separate inequalities. The first one here, this is x is less than negative 5, less than or equal to, I apologize. And then when I have 2 pieces, I write the word or, x is greater than or equal to 3. So that is my graph and my answer. Again, this parabola was just my way of figuring out where would it be above. To the left of -5, in between -5 and 3, or to the right of 3. And if you think of this as a parabola, which it is, it's a quadratic, a positive one, I'm starting above. Okay, that means I'm greater. Now I'm at the number line, which is really where it's 0. Now I'm below the number line, so that's where it's less than, at, and then again above. On letter E, this one is a quadratic. What I'm going to do is I'm not going to work that part out. I'm going to have to. Why am I going to have to? I would not, except for I also have an X over here. So I'm going to have to work that out. So what I'm going to do first is I am going to work out X minus 2 squared. And again, remember, that is really an X minus 2 times an X minus 2. Okay, which you can do in a box or a foil, or use the formula. Remember the formula, a minus b squared, perfect square trinomial, is a squared minus twice my a times b plus my b squared. So I'm going to square my x, which is x squared. I'm going to multiply my -2 and x together and double, so that's a -4x. I'm going to square -2, which is a 4, minus 17 equals 3x minus 8. So now I'm going to distribute. So this is a 3x squared minus 12x plus 12 minus 17 is equal to 3x minus 8. I need to clean up anything that's like terms on this side. So that's going to be a 3x squared minus 12x minus 5. And then what I'm going to do is get everything on one side, 0 on the other. So I am going to basically minus 3x from both sides. I'm also going to add 8 to both sides. So I'm going to get 3x squared minus 15x plus 3 is equal to 0. Now, at this point, I can, if I want, divide everything by 3 and get x squared minus 5x plus 1. That's what I personally would do. Now, we cannot factor this. This is not factorable. So you either want to complete the square or do quadratic formula. I do like to complete the square if it's an x squared, not like a 3x squared like it was a second ago. But I don't like to do it if it's odd. So I'm going to use quadratic formula. And so quadratic formula is used if you have ax squared plus bx plus c equals 0, has to equal 0. And it's going to be x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. That's what I'm going to be doing. So in this case, my a is 1, my b is -5, and my c is 1. So I am going to have x is equal to, opposite of b is going to be 5 plus or minus the square root of -5 squared, which is a 25, minus 4 times my a, which is 1, and my c, which is 1, all over 2 times my 1. And so I'm going to get 5 plus or minus, and it's going to be 25 minus 4, which is a 21, all over 2. And that's my answers. It's not pretty, but that's it. For F, this is one of the ones that you're going to let u equal. So I notice I have a square root here and an x here. So I am going to let u equal the square root of x, and that means u squared is x. So this is going to become my u squared. This is going to become my u. So I'm going to rewrite this 2u squared plus 3u minus 35 equals 0. Okay. And I am going to factor that. So let me factor that. So 2u squared negative 35. That is a negative 70u squared, and it has to add to 3u. So that's going to be a 10u minus 7u. So a 10u minus 7u. And then my factors are going to be a 2u and u on the outside here, plus 5 minus 7. So I am going to get 2u minus 7 times u plus 5 equals 0. So I'm going to get 7 halves, or 3.5, and a negative 5. Now, remember that this was u being equal to the square root of x. So in place of the u, I am going to write the square root of x is equal to 7 halves, and the square root of x is equal to negative 5. The minute you have a square root, you need to stop. You need to look to the other side and make sure it's positive. This is okay. Okay. Over here, look to the other side. This is negative. So this is going to be no solution there. I'm not going to work that one out. So over here, when I square both sides, I'm going to get x is equal to 49/4. And that's your answer. On letter, well, actually, that's the end of that one. So on number 4, we've got more inequalities that we're going to put on a number line. So even if they don't say, hey, put it on a number line, you always put them on number lines. So for this one, I want to get everything on one side, 0 on the other side. So I'm going to add my 22x. This one I can't clean up by like dividing by 3 or anything. So this one I'm going to do factoring. So I'm going to have my box to diamond, and I'm going to have a 3x squared and a negative 16. And that's going to multiply to a negative 48x squared. And it needs to add to the 22x. So if I'm sitting here trying to figure out this, I'm thinking a 24 and a negative 2. So 24x negative 2x. And then when I'm doing this, my 3 is going to go here, my x here. This will be a plus 8. This will be a minus 2. So I'm going to have 3x minus 2, x plus 8 greater than or equal to 0. I am going to get 2/3 as one boundary point and a negative 8 as another. So if I'm putting this on my graph, okay, I'm going to have a negative 8. I'm going to have a 2/3, and I'm just going to copy this. I'm going to have it twice here. One's kind of as my working graph and one's as my like final. So when I'm looking at this, I'm looking at that's greater than or equal to. So that means I am going to have at both of these solid dots. Okay. And then I want to figure out where I am shading. So again, if I'm looking at this, this is a parabola. We want it to be greater than or equal to. So if I'm thinking about a parabola, okay. And let me just get my cursor again here. Okay, thinking about parabola. This would be a positive parabola, so it'd be starting above. Okay, starting above. It's a positive, it's open up. So I'm above at 0, less than or below 0, at 0, above. So again, when I'm looking at this, right here, this is above, this is below, this side I am above, and we want it greater than or equal to. So I'm basically going to want it to be where I am above. So it's going to be here and here. So that's my final graph. And my answer is going to be x is less than or equal to negative 8, and you need the word or. X is greater than or equal to 2/3. So that's my graph and my answer. Okay, on the next one, absolute value of 3x is less than 18. So in this case, I really am going to think of this as an equation to get my two boundary points to start with, okay? So I'm going to work out 3x minus 4 equals 18, and 3x minus 4 equals a negative 18. So I'm going to have 3x is equal to 22, x is equal to 22 thirds. 3x is equal to negative 14, x is equal to negative 14 thirds, okay? So on my number line, let me go back. On my number line, and again, I'm going to draw two number lines here, one as my working one and one as my final one. So this is negative 14 thirds, so it makes it a little smaller. Okay, so this is a negative 14 thirds, and this is going to be 22 thirds. So negative 14 thirds and 22 thirds. Okay, so when I'm looking at this, this is less than, not less than or equal to, so I'm going to have an open circle. That's not going to be included. And then I need to decide where I'm going to shade. Now, this is an absolute value. Okay, we want, where is the absolute value less than 18. So this is really where it is 18. That's at a height of 18 if you're thinking about it as a graph. Okay, that would be at a height of 18. So these 2 points here would be where it would touch 18, okay, a height of 18 on a graph, if I'm graphing this. Absolute value is a V-shaped graph. So I'm going to think about this as a V. Okay. And so as I'm drawing a positive, okay, open up absolute value, I'm starting above. Let me actually get a line tool so I can draw this a little neater. Okay. So I am starting above. Okay. Now I'm at zero, not at zero, sorry, at the height of 18. As I'm starting here, I'm higher than 18. Now I'm at 18. Now I'm less than 18. Okay. And I'm going to continue less than 18, at 18, greater than 18. So again, if I'm thinking about this, here I am above 18. Here I am below 18. This section I am above 18. I want below or less than, okay? So I am not going to be to the left of negative 14 thirds or to the right of 22 thirds. I'm going to be in between them. So I'm going to be shading in between. Okay, that's my answer. So let me just give a cleaned up answer here. So this is where it is. Now, when you're shading in between, you're not going to write it as two separate inequalities. That was an or. This is going to be an and. And so what I'm going to do is I'm going to start with my smaller one, negative 14 thirds, and I'm going to write less than x, still less than, it always points the same direction, 22 thirds. That's my graph and my solution. Okay. On the next page, we are asked to put both of these in graphing form. So for a parabola, that's going to be y equal a, but in this case, we don't have an a, so I'm just going to write it as x minus h squared plus k. For this one, where you have an x squared and a y squared, that's going to be a circle. That's going to be a circle. There's other graphs that have x squared, y squared. We don't know them as of yet. So x minus h squared plus the quantity y minus k squared equals a number. It's our radius squared, but it's just going to be a number. So that's what we want. So we have to complete the square. Okay, so on the first one, what I'm going to do is I'm going to minus my 3 from both sides, and I'm going to give myself some space. Okay. And I'm going to have an x squared minus 8x. what I'm going to do is I'm going to take my b, I'm going to divide it by 2, and then square. So I'm going to take my b, which is -8. I'm going to divide it by 2, which is -4. And then I'm going to square that, which is 16. That's what I'm adding to both sides. Okay. So this is going to be a y plus 13 is equal to, and this is a quantity squared. It is going to be half of -8, which is -4. So this is going to be an x minus 4. Then I am going to minus the 13 back to this side, and there's our equation. I'm going to do the same on b, but this time I'm going to do it twice, once for my x's, once for my y's. So let's get the x's grouped together. So x squared minus 2x plus something here. Okay. Y squared plus 10y. Let me move it, give myself some more space. Plus something is going to equal -4. And then I'm going to add that to both sides. So I'm going to do this twice. Again, I'm going to take my b, in this case, -2, divide it by 2, which is -1. And then I'm going to square that. And a -1 squared is 1. So I'm going to add 1 here and here. I got to do it to both sides. Then I'm going to take the b for my y, which is 10, divide that by 2, which is 5, square that, which is 25. And that's what I'm adding to both sides. And then I'm going to write these as squares. So this is my x, this is my y. And again, when I'm trying to figure out, what goes here, again, I look at my b. Half of -2 is -1. So this is going to be a -1. Half of 10 is 5. So this is going to be a y plus 5. And on the other side, 26 and a -4 is a 22. That's your equation. On number 6, we're trying to write a system of inequalities. So I have 3 graphs here. I have my red one, which is an absolute value. So let's take a look at that one. So that one has a vertex at -1, 3. And if I'm paying attention to how I'm moving, I'm going down 1, 2, over 1, 2, 3. So that's going to be a -2/3 times the absolute value of, let me write this a little thicker. Okay. So it's going to be a -2/3 times the absolute value of x plus 1 plus 3. Now, I need to write an inequality. And so what you'll notice is for this one, I am shading really below it, which is less than. Okay, so this is going to be, because it's a solid line, less than or equal to. Okay. On the next one, let's say I do the line. This line has a y-intercept at -3, and I'm going up 2 over 1. So a y-intercept of -3 up 2 over 1, so 2x minus 3. It's going to be solid. And again, I need to figure out where I'm shading. So for this one, I am shading here, which really is going to be above that line. So that's going to be greater than or equal to. That's what that's going to be. So I am going to have greater than or equal to. Now the blue one is a square root. It's going to be a negative square root because it's going down. It has a starting point at -4, 2. And then as I go out here, the square root of 1 is 1. I went down 1. The square root of 1, 2, 3, 4 is 2. I went down 2. So it's just a regular square root, but it's going to be negative. So I'm going to have a y. I'm going to have a negative square root of x plus 4 plus 2. And then I need to look at where I'm shading. And for this one, I am shading above it. Okay, so that means greater than or equal to. And that's my system of inequalities. On 7, we're writing and solving a system. So we've got hamburgers and hot dogs. I can't use H for, usually I like to use a letter that is in the word, but I can't use H because they're both H's. So I'm going to use B and D. Okay. Burgers and dogs. So I'm going to let B equal cost of a burger. And I am going to let D equal cost of a hot dog. Okay, so I'm going to translate. So this line here says 3 hamburgers and 5 hot dogs cost $25.25. So 3 hamburgers plus 5 hot dogs cost $25.25. Okay. My second one is 4 hamburgers and 2 dogs cost $20.60. Okay, so 4 hamburgers and 2 dogs cost $20.60. And I'm going to solve the system. Now, I think what I'm going to do is I noticed that I could divide everything in this equation by 2 just to make it a little smaller. That would give me 2b plus d is equal to 1030. And so now what I think I'm going to do is I am going to multiply this equation by a -5 because this is a positive 5d. So I'm going to try to get this to be a -5d. So I'm going to multiply everything here by -5. Okay, so let me rewrite the first one. 3b plus 5d equals 25.25. My second one, I'm going to multiply by a -5, so I get a -10b minus 5d is equal to a negative, say 10.3 and 5, a negative 51.50. I'm going to add these together. I get a negative 7b is equal to a 26.20, a negative 26.25. I'm going to divide both sides by -7, and I get B is $3.75 for each burger. Okay, that's how much it costs for each burger. I need to find out how much it costs for a hot dog. So now I'm going to put it into one of them. I think I am going to put it into this one here. So I'm going to go 2 times 375 plus D equals 1030. 2 times 375 gets me 750. And I'm going to subtract 750 from both sides, and I get $2.80. That's how much it's going to cost. Let me just spread this out. $2.80 for a hot dog. Decide if this is even or odd. So a little reminder again, if I put in a -x and I get the same thing back, that's even. If I put in a -x and I get the opposite of the original equation back, that's odd. Otherwise, it's neither. You need to put in a -x. You need to show me what you get, and then you need to tell me what that means. Okay. So I'm going to have 8 times a -x to the 5th over -x to the 3rd minus 5 times -x to the 7th. And this is helpful to understand that if I take a negative and I raise it to an odd, I'm always going to get a negative. Okay. So this is going to become a -8x to the 5th. Again, if I take a negative and raise it to an odd power, I'm going to get a negative. So that's going to be a negative x to the third. Now here, this is going to be a negative 5 times, and again, when I have this negative raised to an odd, it is going to be negative. So that's going to be a negative x to the 7th. So I'm going to have a negative x, 8x to the 5th over a negative x to the 3rd. And here a negative times a negative ends up being a positive 5x to the 7th. So what I want to do is I want to look at that and compare that to this and see what happens. Now, when I have that negative on top here, okay, this negative up here, okay, that negative, I really could, instead of having that negative on top, put that negative on bottom. So what I'm going to do is, instead of having that negative on top, I'm going to put that negative on bottom, which means that's going to make everything on bottom opposite. So I am going to get 8x to the 5th on top. On bottom, negative times a negative is going to give me a positive x to the 3rd. A negative times a positive is a negative 5x to the 7th. And now you see I got the same thing back. So this is even. That is even. What ends up really happening is when my whole top is raised to an odd and all of my terms on bottom are also raised to an odd. When I put in a negative, I'm going to get a negative on top, a negative on bottom, and that becomes a positive. So that's why I end up getting an even back. X and Y intercept. So I'm going to put 0 in for my x's. And when I put 0 in for my x's, what's going to happen, and I can easily just show you here without having to actually compute this, that I'm going to get a positive 18/7, because what's going to happen is any term that has an x is going to be gone. It's going to be gone because it's going to become 0. Okay, so that's all gone. And what am I left with? A negative 18 over a negative 7, which is an 18/7. That is my y-intercept, okay, because I put 0 in for my x and I was solving for y. Okay, now when I'm solving this and I'm trying to get my y to be 0, what has to happen is my numerator has to be 0. So I'm really working out 0 is equal to 2x squared minus 9x minus 18. I'm going to factor that. Okay. And when I factor that, I am going to get a 2x squared here, a negative 18. That is going to multiply to a negative 36x squared, and I have to get a negative 9x. So for that, I'm going to do a negative 12 and a positive 3. Negative 12, positive 3. So that's going to give me a 2x and an x. This is going to be a minus 6. This is going to be a plus 1. So I have 0 equals 2x plus 1 times x minus 6. So my x-intercepts, I'm going to have a negative 1/2 and a 6. On number 10, they're asking us to sketch this. Okay. Now, if you want, you can add in a graph. Okay. Or we can just sketch this since it is asking us just for a sketch. So what's going to happen for this? I am going to have an inflection point at 4,3. So if I go 1, 2, 3, 4, 1, 2, 3, I have an inflection point there. It is going to be a 1/2, which is going to actually make this look a little wider. Okay. But I'm just going to do a sketch at this point. It is going to be solid. Okay. And I'm just going to sketch. So for this, I want it to be less than or equal to. So if I go to my inflection point, okay, and I go down, this is going to be less than this side. If I went up, I'm over here. I'd be shading this. Okay, so again, I want less than, and less than or equal to is over here. So I'm going to have everything here. The equation of this circle, this point here is at -2, -3. And so then I want to figure out how far I'm moving. Well, that's going to be 2. So my radius is 2. So this is going to be x plus 2 squared because of this point, plus y plus 3 squared. It's going to be opposite of each of those when it's in the parenthesis. And then my radius is 2. So I'm going to go 2 squared. Now we don't write it like that. We're going to actually do the math and write it as a 4 because 2 squared is 4. That's our equation. On number 12, what is the equation of this one? This is a absolute value. It has a vertex at 2, 0, and it's going down. And it looks like I'm going down to every 1. Sorry, down 1 every 2. So that means I'm going to have a -1/2 as my stretch. So this is going to be y is equal to a -1/2 times the absolute value of x minus 2. You could put plus 0, but you don't need the plus 0. And that's your answer. Okay. On these ones, we're graphing. It doesn't say sketch, it does say graph. So I'm actually going to add a graph on here. So I'm going to go to add media, and I'm going to come to this, and I am going to add a graph in. I am going to type in blank graph. And find one that I like. Okay, this one's got some numbers on it. Let's see. And then I can make it bigger. And I'm gonna come here, select, copy, paste, get another one. And let me do it again over here. Okay, so for this one, when I am graphing this is a cubic graph. It has an inflection point at 2, 3. So I'm going to go to 2, 3. Okay, so 2, 3. And then from there, it is negative. Okay, and this is a cube. So if I go out 1 cubed is 1, times it by a negative, I'm going to go down 1. 2 cubed is, so if I go out 2 cubed is 8. I'm going to times that by a negative. So I'm going to go down -8. So that's 3. So I'm going to be down here at -5. Now going the other direction from this inflection point, if I go out 1, -1, -1 cubes and -1, but when I times it by a positive, I get a +1. And so I would also do the same going out -2, and I would go up 8. It's not going to fit on this graph, so I'm not going to do that. And so again, just to emphasize, this is my inflection point right there. Okay. So that's where I'm going to be kind of changing it from almost like an, let me get a different color. And I'm going to draw this a little lighter so you can see my points. Okay. So it's going to be almost like an open up, half of a parabola, to an open down, kind of that type of a shape. Okay, on B, this is a square root graph. And for the square root graph, we have to be careful. A couple things. This negative instead of a normal one looking like this would be the square root of x. If I have a negative in front, that's what I get. If I have a negative underneath, what happens is instead of going to the right, I'm going to go to the left. And if I have a negative in front of that, I am going to go to the left, but instead of going up, I'm going to be going down. So you'll notice I have a negative and then my x is negative. So you got to be careful. It's actually going to go to the left and down. So I am looking to see what makes this 0. And that is actually going to be a 5. A positive 5 would make that 0. And then -1. That's going to be my my starting point. So I am going to come here to 5, -1. And then instead of going this direction, it's going to go this direction. And instead of going up like it normally would, okay, or up this direction, since it has a negative for the x, it's going to go down. So I come out 1. The square root of 1 is 1. So instead of coming out 1 this direction, I'm going to go 1 this direction. And instead of going up, I'm going to go down because, again, it's like this type of a graph. Okay, so now if I go out 1, 2, 3, 4, because the square root of 4 is nice, that would be 2. If I went out 9, so that's 5. This would be 9. The square root of 9 is 3. And then I can graph my square root. On C, this is an exponential. This will have a asymptote at y equal 4. So I am going to draw in at y equal 4. Okay, so this is my dashed line at y equal 4. Okay, and I'm going to write y equal 4. And then from here, the way I like to think about it, again, we kind of have a point at 5, 4. That's like a critical point. It's not actually on the graph, but instead of going to 5, 4, which would be here, I just come to my asymptote where it touches the y-axis. I know that everything's been shoved up 4, okay? This is saying that I'm going to the right 5. So I'm going to go to the right 1, 2, 3, 4, 5. And this is where I'm going to start plotting 3 to a power. 3 to the 0 is 1. 3 to the first is 3. 3 to the second would be 9, and so forth, okay? Obviously, I'm not going to be able to continue graphing all of that. And so here is my exponential. And that's the end of this video. Again, when we're doing this, you want to make sure that you understand how to do these without my video, without notes, without any starting hints, because you won't have that for the test.